So just finishing up the tail end of this chapter here, a third trend that your book talks about is metallic character. Metals and nonmetals behave differently. Metals tend to lose electrons when they react chemically. Nonmetals tend to gain electrons. When we move across a period in the periodic table, and when they say across, they mean from left to right, we talked about how the ionization energy increases. That means that electrons are less likely to be lost. The metals are on the left side. The metals are more likely to lose electrons. So metallic character, how metallic an element is, decreases as you move to the right across a period, and it increases as you go down. It follows the same trend as atomic size. So here's a picture, because I've got to have a picture here. So here's the arrows that the book is telling you about the trends. Okay, I think there's a much easier way to remember this particular trend. What color should we be today? How about green? Just a nice green. So let's take this row, maybe nitrogen, column 5, group 5A. What kind of an element is nitrogen? A metal or a nonmetal? A nonmetal. And as we go down, arsenic and antimony, you're probably not familiar with them, but they're right next to this stair-step line. So what kind of elements are they? They're metalloids or semi-metals, right? Is that more or less metallic than a nonmetal? More. And what about bismuth? We can tell from the colors here, bismuth is a metal. So as we're going down this group, are things getting more metallic or less? More. That's a lot simpler than the other things we were talking about, huh? Let's take period 4. Krypton is a noble gas. Bromine, these are nonmetals, right? These are semi-metals. And over here, zinc, copper, nickel, we recognize those from just general being alive as being metals, right? So the trend as you go across here, is it getting more metallic or less? Less. Okay? So it should be fairly simple to pick out the trend in metallic character, even from a blank periodic table like this, recognizing this stair-step line is the division between the nonmetals and the metals. As you're going across, are you going to metals or nonmetals? There's the trend. And then you can use that to remember the other two trends. That trend is the same. Oops, that's not what I wanted to do. See, it's the same trend as atomic size. So metallic character and atomic size go the same direction. The ionization energy was the opposite. So that's a different way of remembering the trend. So, example, choose the more metallic element from each pair. Tin, SN or TE. So we look at these. Here's SN and TE. Well, we don't even really need to think about a trend there, do we? Because tellurium, Te, is in the semi-metals, the metalloids. So that's going to be less metallic than tin, which is in the metals. So the more metallic would be the tin. How about comparing tin and silicon? Here's silicon. I'm sorry, that's tin and silicon. Whatever. Tin's more metallic. How about bromine and tellurium? Well, this one, we can see, this guy's right along that stair-step line. So that's a semi-metal, metalloid, and bromine is a nonmetal. So Te must be more metallic.
So an atomic size, what would be larger?
In atomic size, going across, the bromine would be expected to be smaller, and coming down, atomic size increases, and so the bromine would also be expected to be smaller. So that does have the reinforcing trends. Then this last one's going to be a little different, iodine and selenium. We can't tell that one. Because we look at these are both nonmetals. And if we look at the trend, going across becomes less metallic, so we expect the iodine to be less metallic than the selenium. But going down, we expect the iodine to be more metallic. And so we don't have enough information for that one. Any questions? And that was the end of the chapter. Little tiny bit we couldn't fit in. Chapter 9 in review. Bunch of slides. May or may not be helpful.